My name is Albert Einstein, and today I will tell you the most dangerous idea in physics. It is an idea so powerful that once you understand it, reality will never look the same again. It destroys common sense. It challenges time itself. And it forces us to ask a terrifying question. What if time is not real at all? Physics is not simply a collection of numbers. It is a way of seeing, a way of asking questions so deep, so fundamental, that the answers do not merely change what we know, they change who we are. Some ideas in physics are useful, some are elegant, but some ideas are dangerous. Not dangerous because they cause harm, dangerous because once you truly understand them, once they settle into your mind, you cannot return the comfortable world you lived in before. Today, I will share with you the most dangerous idea in all of physics, and I will ask you only one thing in return. Stay with me. What makes an idea dangerous? Before I answer that question, let me explain what I mean when I call an idea dangerous. Think about this for a moment. When Galileo looked through his telescope and told the world that the Earth was not the center of the universe, that we move around the sun, not the other way, it did not merely change astronomy. It shattered a belief that billions of people had held with complete certainty for thousands of years. That is a dangerous idea, not because Galileo was wrong, but because he was right. Then came Darwin, who proposed that life itself was not fixed, but evolving, changing, shaped by time and pressure over millions of years. Again, dangerous, not because it destroyed us, because it freed us from a comfortable illusion. These ideas share something important. They break what I call the tyranny of intuition, the feeling that the world must work the way it seems to work. And the most dangerous idea I ever encountered did exactly this. It did not ask us to reconsider where we stand in the universe. It asked us to reconsider when. The most dangerous idea in physics is the idea that time itself is not absolute. This is where things become strange. To understand why this is dangerous, you must first understand what we believed before. For most of human history, and for most of the history of science, time was considered the one thing that never changed, the one constant in a universe full of variables. A second was a second, everywhere, always, for everyone. If you stood in London and I stood in Paris, and we both measured the passage of 1 hour, we would agree, exactly, on how long that hour lasted. A clock in a palace and a clock in a village would tick at precisely the same rate. This was the worldview of my great predecessor, Isaac Newton. Time, he said, flows equally and without relation to anything external. Space was fixed, absolute, a stage upon which the drama of the universe was performed. And this made sense. It matched everything ordinary human experience told us. Think about your own life. You wake in the morning. An hour passes over coffee. Another hour passes at your desk. Time moves forward, steadily, reliably. It does not speed up or slow down, not truly, not physically. Or so we thought. Newton's universe was a beautiful machine, orderly, predictable. Time was the axis upon which everything turned, perfectly consistent, perfectly neutral. It was a deeply reassuring picture. But nature had a different plan. It began with light. Light travels at approximately 300,000 kilometers every second. But what kept me awake as a young man, working in a patent office in Bern, thinking about the cosmos, was not how fast light travels. It was how light behaves. Now here is the shocking part. Imagine you are standing on a train platform. A train rushes past at enormous speed. Someone on that train throws a ball forward from your position on the platform. The speed of that ball is the speed of the throw plus the speed of the train. Simple, intuitive. Velocities add together. Now replace the ball with a beam of light. You would expect the same thing. Light from a moving source should travel faster, because the motion of the source should add to its speed. But it does not. No matter how fast the source moves, whether stationary, approaching, or retreating, light always arrives at exactly the same speed. Always, without exception. I ask myself, what if we simply accept this as true? What if the speed of light is a genuine, absolute law of nature? If we accept this, then something else must give way. And what gives way is time. If two observers moving at different speeds must both measure light at the same speed, their measurements of time and space cannot be identical. The mathematics demands it. Time itself must stretch and compress depending on how fast you are moving. And this is where the dangerous idea begins. Let me say this plainly, and then I will show you what it means. Time is not the same for everyone. Depending on how fast you move, and depending on how much gravity surrounds you, time passes at a different rate, not as a perception, not as a feeling, as a physical, measurable, verifiable fact. Let me show you something surprising. Imagine time as a river. Most people believe that everyone floats on the same river at the same speed and the same current. 1 second for you is 1 second for me. 1 hour here is 1 hour everywhere. The river of time flows equally for all of us, but relativity tells us something entirely different. Each person is floating in a different river, flowing at a different speed, depending on emotion and the gravity around them. Some rivers run fast, some run slow, and none of them are wrong. They are simply different. Now, let me give you 3 examples that make this real. Consider an astronaut who leaves Earth aboard a spacecraft traveling at a very high speed, a significant fraction of the speed of light. She is gone by her own clock for 5 years. She returns to Earth and finds that 50 years have passed on the planet she left behind. Her twin brother, who stayed behind, is now an old man. She is still young. This is not science fiction. It is the direct consequence of the equations of special relativity. Now consider gravity. Gravity, as I later discovered, is not merely a force. It is a curvature in the fabric of space and time itself. Where that curvature is most severe, near a black hole, near any massive object, time slows dramatically. A clock placed near a powerful gravitational source ticks more slowly than one placed far away. This has been measured. It is real. And here is the 3rd example, the one that unites both. 2 observers, one moving fast, one standing still, one near a massive object, one far from it. They experience time differently. They age differently. They live in different rivers, flowing at different speeds. Neither is wrong. Neither is experiencing an illusion. There is no universal now. When you look at the night sky and see a distant star, you are not seeing that star as it is. You are seeing it as it was thousands, perhaps millions of years ago. By the time its light reaches your eyes, that star may no longer exist. The past and the present coexist in the same sky. And here is the deepest implication of all. If time is relative, if it bends and stretches and flows at different rates, then in the mathematics of relativity, all moments in time exist as coordinates in a 4-dimensional landscape. The past does not disappear. The future does not fail to exist. They are all simply there. Past, present, and future may exist simultaneously. If time is not real, then what is reality? Now you begin to see why I call this dangerous. But here is the real danger. The first level is the simplest. It destroys common sense. Human beings are built to trust time. We feel it in our bodies, in hunger and fatigue, in the rhythm of seasons. Our entire civilization, our laws, our calendars, our sense of history, rests on the assumption that time moves equally for everyone. And relativity tells us that this assumption is, at a fundamental level, wrong. The second danger is deeper. If time is not fixed, then reality itself becomes unstable in a way we find profoundly uncomfortable. What is now for you is not now for someone moving at a different speed. There is no single moment that is simultaneously present for all observers in the universe. There is no cosmic clock. There is no synchronized presence shared by all things. The third danger is philosophical. If the future already exists, if it is simply a coordinate we have not yet traveled to, then questions about choice, about free will, about the meaning of our decisions become extraordinarily complicated. I do not claim to have resolved these questions. I am not certain anyone has. But I know this. The universe does not care about our comfort. I once wrote, and I believe this with complete conviction, that the distinction between past, present, and future is only a stubborn illusion, not a poetic observation, not a metaphor, a conclusion drawn from the most precise physics we possess. The universe is stranger than our intuition allows, and this changes everything. I do not share these ideas to unsettle you without purpose. Think about this for a moment. Consider something as ordinary as the navigation device in your pocket. the one that tells you exactly where you are on the surface of the Earth. The GPS satellites that make this possible orbit at high altitude and travel at significant speed. Because of this, relativity predicts that time on those satellites runs at a slightly different rate than time on the ground. Faster due to weaker gravity, slower due to their velocity. If the engineers who designed GPS had ignored the equations of relativity, if they had assumed time was absolute, as Newton did, your navigation would drift by kilometers every single day. The entire system would collapse. The dangerous idea keeps your world running. Then there are black holes, objects so massively dense that the curvature of space-time around them becomes extreme. Near the event horizon of a black hole, time slows nearly to a stop. A traveler falling inward would, from the perspective of a distant observer, appear to freeze, suspended at the boundary between the known and the unknowable. Now here is the shocking part. In the future, as spacecraft travel to distant stars, time dilation will not be a theoretical curiosity. It will be a lived reality. Crews may return from long voyages to find that centuries have passed on the Earth they left behind. We are only beginning to understand what this means. But beyond technology, beyond space travel, beyond all the extraordinary things we have built with these ideas, the deeper lesson is this. The universe is not simple. It does not owe us simplicity. It does not owe us comfort or intuition or a reality that makes immediate sense to creatures who evolved on one small planet. And the most important thing any human being can do, the most important thing you can do, is meet this complexity with openness rather than fear. Curiosity, I have always believed, is more powerful than certainty. So what should we learn from this dangerous idea? Physics, in the end, is not merely a science. It is the most honest conversation we have ever had with the universe. We ask questions. We listen carefully. And the universe answers, not always in ways we expect, not always in ways we find comfortable, but always in ways that reward the asking. Time is not absolute. Reality is not fixed. The universe you inhabit is stranger and deeper and more wondrous than the one your ordinary senses present to you each day. And I have always believed, that this strangeness is not a reason for despair. It is a reason for wonder. We are creatures who evolved to survive on one small world, under one modest sun, in one ordinary corner of an incomprehensibly vast cosmos. And yet, through mathematics and observation and the sheer audacity of curiosity, we have begun to understand how that cosmos truly works. That is extraordinary. So let me leave you with this. The most dangerous idea in physics is not that time is relative. It is not that the present moment is an illusion, or that the future already exists somewhere in the geometry of space-time. The most dangerous idea is that reality is far stranger than we ever believed, and that we are only just beginning to find out how strange it truly is. The universe is not built to be understood easily, but the fact that we can understand it at all may be the most beautiful mystery of all. Keep asking, keep wondering, keep questioning the universe. And if you are